Now we turn MCP from an idea into something you can run. We'll build the smallest useful server, expose one simple tool, connect a local client, and prove that discovery and execution work before adding production complexity. Before writing code, let's connect this to what you already know: the MCP mental model, common architecture patterns, and the server lifecycle, including capabilities and client interactions. In this module, we'll build a minimal server first, then use it as the foundation for production-ready design. Treat the first MCP server as a teaching model, not a production service. It needs to do three things well: start reliably, announce what it can do, and let a client invoke one safe operation. That first operation should usually be read-only, deterministic, and easy to verify, such as a simple data query. The key test is the full loop. The client discovers the tool, sends a request, the server runs it, and returns a response. Keep the code small but structured so the next tool fits naturally. A minimal MCP server is essentially a disciplined message router with a catalog of abilities. The client initializes the connection, then asks what tools are available. The server runtime handles the protocol work, accepting messages, validating them, and dispatching requests to the right tool definition. Each definition names the tool, its inputs, and its expected result shape. The handler runs the application logic, and the server returns the outcome as a structured response the client can reliably use. Good project structure is less about neat folders and more about protecting future change. Keep server startup thin. Load configuration, register tools, and start the process. Put tool definitions and business logic in their own modules with validation schemas nearby, so contracts stay visible. Tests should mirror the source structure, making it obvious where coverage belongs as the code base grows. Treat configuration as part of the project, not tribal knowledge, so another developer can run the server repeatably. In practice, a minimal MCP project should make responsibilities obvious. Keep server startup and tool registration in RC server, and place each tool's schema, definition, and handler together under SRC tools. Mirror that structure in tests, so behavior is easy to validate as tools grow. Configuration belongs in environment examples or config files, not hard-coded in source. This keeps the entry point small, the tools reusable, and the project easy to navigate. The entry point is the runtime's assembly step. It loads configuration, creates the MCP server, and registers every tool and capability the client should be able to discover. Registration must happen before listening starts. Otherwise, the client may see an incomplete server. Next, the entry point attaches a transport. For local development, standard input and output are often enough, while deployed systems may use sockets or another channel. Finally, it starts the loop and waits for messages. Keep this file thin, and if startup fails, fail fast with clear diagnostics. Capability discovery is the client's first view of your server. When the client asks what you can do, the server should answer with only the features it truly supports. For a minimal MCP server, that usually means a clear tool list such as get status, plus useful metadata describing what the tool does and how to call it. Avoid advertising resources, prompts, or advanced behavior you have not implemented. Accurate, minimal capabilities keep the client experience predictable and reduce failed or confusing requests. A tool definition is the contract that lets the client call your server safely and predictably. Start with an action-oriented name, like get service status, so the intent is obvious. Add a description that tells the model when to use it, not just what it is called. The input schema becomes the validation boundary. Even if there are no parameters, define that explicitly. Then return structured output, such as status, retries, and response time, so the result is readable by people and usable by the model. For your first MCP tool, choose something that observes rather than changes state. A status lookup is a good example. It reads a known source, applies tight filters, and returns a small, predictable response. That keeps operational risk low while you learn the request and response pattern. It also makes testing easier, because the same input should produce the same kind of output every time. Just as important, sanitize the response. Do not return secrets, stack traces, host names, or infrastructure hints. Save state-changing tools for later, when authorization, failure handling, and rollback are designed. The input schema tells the client what to send and protects the server from guessing. Define every field clearly: type, required status, allowed values, defaults, and limits. Validate before the handler runs, so bad input never reaches business logic. When validation fails, return a structured error that helps the caller fix the request without exposing internal details, stack traces, or sensitive data. Even simple tools deserve this discipline. The tool handler is where a registered tool becomes real application behavior. By the time this function runs, the input should already be validated, so the handler can focus on the operation itself. In a minimal server, that might simply return a status object with a service name and timestamp. The important qualities are predictable fields, no hidden side effects, and errors handled consistently. Keeping this logic separate from registration makes it much easier to unit test, reuse, and change without touching the protocol plumbing. Free-form text may sound friendly, but it is hard for a client to trust or automate. Everything looks fine, leaves the app guessing what was checked, when, and for which service. Structured output turns the same answer into usable data: status, service name, timestamp, source, and key values. That makes results parsable, displayable, and comparable across tools. Keep the shape consistent, include the context that matters, and avoid leaking internal reasoning or extra noise. The goal is not more text. It is a clearer contract between model and client. A minimal MCP server is not done when the code compiles. It is done when a real client can use it end-to-end. Run the server with the same transport you configured, and watch for clean initialization. Then connect an MCP-compatible client and confirm the handshake succeeds. Check discovery next. The tool should appear with the expected name, description, and schema. Finally, call the tool with valid input, then with invalid input. You want both paths verified: structured success data and clear, predictable error behavior. You now have the core pattern for a working MCP server. Organize the project, define clear tool contracts, keep handlers focused, and test through a real client loop. That gives you confidence in the full protocol path, not just the code. Next, we move beyond the demo and make the server production ready: secure, observable, deployable, and governable.